Space is vast, it is dark and cold. Planets, including our own Earth, orbit stars. Stars provide light and warmth, but what if Earth left its orbit? What if Earth became a rogue planet? A rogue planet is a planet without a star. It wanders through space alone. No sun to warm it, no light to nourish it. A chilling thought, isn't it? Imagine Earth, our home, adrift in the emptiness of space. The sun, once a blazing beacon of life, shrinks to a distant point of light. Temperatures plummet, plunging our planet into an eternal icy grip. This is the scenario we'll explore. Earth as a rogue planet. We'll delve into the science, the consequences, and the possibilities, examining the challenges and opportunities of such a cosmic shift. The sun is Earth's lifeline. It is the central star of our solar system, a massive ball of burning gas that provides the essential energy needed for life on our planet. Without it, Earth would be a very different place. It provides the energy for life. Plants, through the process of photosynthesis, convert sunlight into chemical energy, forming the base of the food chain. This energy is then passed on to herbivores, and subsequently to carnivores, sustaining the entire ecosystem. It drives our weather patterns. The sun's heat causes the air to warm and rise, creating wind and weather systems. These patterns distribute heat and moisture around the globe, making different climates and weather conditions possible. It keeps our planet warm and habitable. The sun's energy maintains the Earth's temperature within a range that allows liquid water to exist, which is crucial for all known forms of life. But without the sun's energy, Earth would quickly transform. The absence of sunlight would lead to a cascade of catastrophic events, starting with the loss of light and heat. The most immediate effect would be a drastic drop in temperature. Within a week, the average global temperature would fall below freezing, making the planet inhospitable for most life forms. Within days, the average global temperature would plummet far below freezing. The surface of the Earth would become a frozen wasteland, with ice forming on lakes, rivers, and even the oceans. Oceans would begin to freeze, starting at the poles and gradually creeping towards the equator. This process would take several months, but eventually the entire surface of the oceans would be covered in ice. Within years, Earth would be encased in a thick layer of ice. The planet would resemble a giant snowball, with temperatures continuing to drop as the heat from the sun's absence dissipates. The atmosphere itself would begin to freeze out, with gases like carbon dioxide and nitrogen condensing onto the surface. This would lead to a thinning of the atmosphere, making it even more difficult for any remaining life to survive. The once vibrant blue planet would become a barren, frozen wasteland. The lack of sunlight would mean no photosynthesis, leading to the collapse of food chains and ecosystems. This deep freeze would have a catastrophic impact on Earth's delicate ecosystems, leading to a mass extinction event unlike anything our planet has ever seen. The loss of the sun would mark the end of life as we know it, turning Earth into a lifeless, icy rock drifting through space. Life on Earth is incredibly diverse. It has adapted to extreme environments. But could anything survive on a rogue Earth? The answer, surprisingly, might be yes, but only in certain pockets. Deep beneath the frozen surface, geothermal vents would continue to spew heat from the Earth's core. These vents, often found in the deepest parts of the ocean, support unique ecosystems that rely on chemical energy rather than sunlight. These deep-sea communities, thriving in darkness and extreme pressure, could potentially survive even on a sunless Earth. Extremophiles, organisms that thrive in extreme conditions, offer a glimpse into the resilience of life. However, the vast majority of life on Earth, including all plants and animals that rely on photosynthesis, would perish. The surface would become a desolate wasteland, devoid of any visible life. Section 4. The search for warmth, geothermal havens. With the surface uninhabitable, any surviving humans would need to adapt. They would need to find new sources of energy and warmth. This is where geothermal energy could play a crucial role. Geothermal power plants, harnessing the heat from the Earth's interior, could provide a sustainable source of energy for underground colonies. These colonies, built near geothermal vents, could offer protection from the extreme cold and radiation of space. Imagine a network of underground cities powered by geothermal energy, where humans cultivate food in hydroponic farms and maintain a semblance of their former civilization. While challenging, it's not beyond the realm of possibility. The key to survival would be adaptation, innovation, and a collective will to persevere in the face of unimaginable adversity. Section 5. humanity in peril, a fight for survival. The transition to a rogue planet would be a perilous journey for humanity. As Earth drifts away from the sun, the very source of life and energy, we would face unprecedented challenges. The warmth and light that have sustained life for billions of years would be lost, plunging our world into a cold, dark abyss. The extreme cold, the lack of sunlight, and the collapse of ecosystems would pose significant challenges to our survival. The once vibrant landscapes would turn into frozen wastelands, and the delicate balance of nature would be disrupted. Plants and animals that rely on sunlight would perish, leading to a domino effect that would threaten the entire food chain. Food production would be a major concern. Traditional agriculture, which depends on sunlight and favorable weather conditions, would become impossible. The fields that once provided bountiful harvests would be buried under layers of ice and snow, and greenhouses would struggle to maintain the necessary conditions for plant growth. Traditional agriculture would be impossible, forcing us to rely on alternative methods like hydroponics and even lab-grown meat. These innovative techniques would become essential for our survival, allowing us to grow food in controlled environments. Scientists would work tirelessly to develop new ways to produce food, ensuring that we have enough to sustain the population. Resource scarcity would lead to competition, potentially sparking conflicts for survival. As resources become limited, tensions would rise, and communities might find themselves in fierce battles over the remaining supplies. The struggle for survival could bring out the worst in humanity, leading to violence and chaos. However, humans are an ingenious species. Throughout history, we have faced numerous challenges and have always found ways to overcome them. Our ability to innovate and adapt has been our greatest strength, and in this new frozen world it would be no different. We have a long history of overcoming adversity. From the Ice Ages to the Industrial Revolution, humanity has always risen to the occasion. Our resilience and determination have allowed us to thrive in the face of seemingly insurmountable odds. In this new frozen world, our ingenuity and adaptability would be put to the ultimate test. We would need to develop new technologies and strategies to survive in the harsh conditions. Underground cities with advanced technology could provide shelter and warmth, while spacesuits and other protective gear would allow us to venture out into the icy wilderness. The question isn't whether we could survive, but how we would choose to survive. Would we come together as a global community, pooling our resources and knowledge to ensure the survival of our species? Or would we allow fear and desperation to drive us apart, leading to division and conflict? Would we band together and pool our resources, or would we succumb to division and despair? The choices we make in the face of this crisis would determine the future of humanity. Cooperation and unity would be our best hope for survival, while selfishness and greed could lead to our downfall. The fate of humanity would hinge on our ability to unite and innovate. By working together and embracing our collective ingenuity, we could overcome the challenges of this new world and build a brighter future for generations to come. Section 6. Cosmic Wanderers, the formation of rogue planets. How do planets become rogue in the first place? This question has intrigued astronomers and astrophysicists for decades. Rogue planets, also known as interstellar planets, are planetary mass objects that have been ejected from their original star systems and now drift through the galaxy untethered to any star. These lonely wanderers are fascinating because they challenge our understanding of planetary formation and dynamics. These cosmic wanderers aren't born in isolation. They often start their lives in bustling solar systems, where they form from the same swirling disks of gas and dust that give birth to stars and other planets. In these early stages, the gravitational forces at play are incredibly complex and dynamic. They often start their lives in solar systems just like our own. In these young systems, planets can form in a variety of ways, from the gradual accumulation of dust and gas to the more violent collisions of larger bodies. Over time, these processes can lead to the formation of fully fledged planets. One leading theory suggests that gravitational interactions between planets in a young solar system can sometimes eject a planet outward. This can happen when a planet gets too close to a larger planet, whose gravitational pull can slingshot the smaller planet out of the system entirely. This process is known as planetary ejection and is thought to be a common occurrence in the chaotic early stages of solar system formation. Imagine a cosmic game of billiards, where a planet gets knocked off course by the gravitational pull of a larger sibling. This analogy helps us understand the violent and unpredictable nature of young solar systems. where planets can be thrown into wildly different orbits or even ejected into interstellar space. Another possibility is that rogue planets form independently from collapsing clouds of gas and dust. In this scenario, a dense region of a molecular cloud might collapse under its own gravity, but not have enough mass to ignite nuclear fusion and become a star. Instead, it could form a planet or a substellar object known as a brown dwarf. These clouds, lacking the mass to form a star, could still coalesce into smaller planetary bodies. Over time, these bodies might drift away from their birth clouds and become rogue planets. This process highlights the diversity of planetary formation mechanisms in the universe. Regardless of their origin, rogue planets are a fascinating testament to the dynamic and often chaotic nature of our universe. They remind us that planetary systems are not static, but are constantly evolving and changing. The discovery of rogue planets has opened up new avenues of research and has challenged our understanding of what it means to be a planet. They are reminders that our solar system, with its stable orbits and life-giving star, is a cosmic oasis in a vast and unforgiving expanse. The existence of rogue planets underscores the uniqueness of our own solar system and the delicate balance that allows life to thrive here. As we continue to explore the cosmos, the study of rogue planets will undoubtedly yield more surprises and deepen our understanding of the universe.